In this video, we will talk about the second type of trigonometric integral. So in the previous video, we talked about the first type. The first type is you have integral and then sine times cosine raised to some power. So sine has its own exponent, cosine has its own exponent. In type 2, we have tangent times secant and tangent raised to some power, secant raised to some power. There are two cases. Case 1. Before we start, this video is all about the cookbook recipe. I am not solving any integrals in this video. I would just want to show you in case 1, you have to do such and such, and then in case 2, you have to do this and this. Right? So in case 1, when the secant has even power, so when secant has even power, the power of secant is represented by n. N is equals to 2k, k is greater than 2, k it must be some integer. So when you have an integer like 1, 6, 10, 11, you multiply that by 2, whatever the integer is, after you multiply by 2, the product must be even, all right? And then when you see this, first you have to factor out secant square, all right? You have to factor out secant square. And then in the second line, I said that you have to use the fundamental identity secant square x equals to 1 plus tangent square x, and then the integral looks like that. You have integral tangent raised to the nth power and secant raised to 2k power. So you have a secant raised to an even power. All right, and then here is the way you split them up. So in the second line, do you see that on the very right hand side of the integrand, I factor out secant square. I already underlined that for you. So I factor out secant square, the tangent to the nth power, do not touch that, keep that in the integrand. But what about the leftover? So since you factor out secant square, what you have is inside the parenthesis, just keep in mind, this is very important. Inside the parenthesis, you have a secant square x. This cannot be changed, all right? Inside the parenthesis, you have a secant square x. But what about the k minus 1? How do you get the k minus 1 in there? So if you look to your right, I did a little math for you. So 2 and then raise the whole thing to k minus 1. That means you multiply the 2 and the k minus 1, right? So when you multiply the 2 and the k minus 1, you have 2k minus 2, and you factor out a second power, so 2k minus 2, you add 2 to it, now you get the 2k back. Just take a look at the second line. 2 times k minus 1, 2 times k, 2 times 1, then that will be 2k minus 1, and you factor out a second power. After you add the second power back, then you have the 2k back, all right? And then the next thing is you have to use the fundamental identity. Let the secant square equals to 1 plus tangent square, and then you perform a u substitution by letting u equals to tangent x. All right, so that is the first case. And then the second case is tangent has an odd power. So the power of tangent is m. M is equals to 2 times an integer plus 1. So when you double up an integer, you get an even number, right? So even plus 1 is always odd. So in this case, you have to factor out secant x and tangent x. And then you have to use the fundamental identity. So in the given integral, you have tangent raised to 2k plus 1. So 2k plus 1 means odd. You have tangent raised to odd power times secant to the nth power, and then x dx, right? And then immediately you have to factor out a secant and a tangent. So I already underlined that for you. I put that right in front. You factor out a secant times tangent. And then the next thing is, inside the pink parenthesis, you have a tangent square. That must be a tangent square. There is no other exponent that you can use. Again, inside the big parenthesis, it must be a tangent square. And then tangent square raised to the k power. And then you might ask me, hey, 2k and 1, how do we get the 2k plus 1? So 2, and then you have a k, so that will be 2 times k. And then you still factor out a tangent, then 2k plus 1, then you get the 2k plus 1. The secant raised to the nx, do not touch that. And then the next step is you rewrite the tangent square as secant square minus 1. After that, you use the u substitution by letting u equals to secant x. So that is the cookbook recipe for the second type of trigonometric integral. And in the next video, I will give you a couple examples for case 1 and then a couple examples for case 2. Alright, so if you think my instruction is helpful, let me know in the comment below, like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. I will see you all in the next video for those two cases. Signing off for now.